In September 1952, the foundations of the valve tower were in process of construction, as was also the main dam. For this gigantic operation, it was necessary to excavate, transport, dump and consolidate 1.5 million tons of gravel. 300,000 lorry loads were carried during the first 2 years, something like 500 lorry loads every day. When finished, the dam was 1.5 miles long, having a roughly triangular section 61 feet high, 440 feet wide at the base, and containing over 1 million cubic yards of gravel. The workmen went down 30 feet below ground to reach suitable London clay on which to found the watertight core. The special clay for the core itself was readily available on the site. An elaborate system of conveyor belts carried the clay from the point of extraction to the so-called sausage machine, where the puddle was prepared according to a time-honored procedure. Knives, driven by a 50-horsepower motor, finally minced the clay, and then water was added until the puddle which emerged was of exactly the right consistency. It was cut into lumps for transport to the puddle trench, where men wearing heavy boots peeled it down into a solid mass. The clay was prepared in this way for the full length of the dam, thus forming a mighty, though invisible wall right down the middle, upon which the water tightness and safety of the reservoir depend. In the second year of construction, important work was proceeding. 9 miles of 48-inch steel pipe were needed to carry the water from Langford to Hanningfield, and the laying of this aqueduct was well advanced by this time. The pipes were bitumen-lined and sheathed with asphalt, each joint being welded. The sections were welded internally, while outside men were fixing electrodes to protect the pipes from electrochemical corrosion, which might otherwise have been set up by contact with the clay in which they were laid. And all this so that you can turn a tap and fill the kettle to make a cup of tea. Nine miles away, the River Chelmer was being drained and temporarily diverted to allow the laying of the aqueduct at the point where it passes under the river near the Langford Works. The pipes were completely encased in a layer of concrete, great care being taken to ensure that the top level of the concrete would not interfere with future deepening or drainage operations. This peaceful Essex River soon recovered from its major operation, and the passage of time has restored its former beauty. To return to Hanningfield itself, considerable progress was to be seen near the valve tower in the second year of construction. A little removed from the valve tower and a little to the east of it, the building of the purification plant was going forward according to plan. These circular erections are to become the accelerators, which we shall see later play an important part in the treatment of the reservoir water. The following year, 1954, the valve tower was almost finished. A start had been made on the concrete slabbing on the embankment, and from the top of the tower, the site was beginning to look more like a reservoir dam and a little less like a muddy playground for giant machines. The mixing of the concrete for the embankment and for other constructional work continued 7 days a week. The slabs themselves were laid by this ingenious machine. When the slabbing was in position, a sweeper was employed to clean the surface. Nine months later, the Langford-Hanningfield main aqueduct was carrying water, and a temporary pump lifted 3 million gallons per day into the reservoir through this inlet. Pumping up to 35 million gallons a day will be possible when the full pumping equipment is installed. The inlet weirs are designed to create a turbulence which assists in oxygenating the water, a process which continues in the reservoir during its exposure to the air over the long period of storage before it is finally drawn off. Not only does long storage assist in the purification of the water, but it also reduces total hardness. Meanwhile, the equipment was being installed in the main pumping station. Provision has been made for 8 vertical spindle centrifugal pumps driven by NS variable speed AC motors, the speed being controlled by induction regulators. This type of motor was specified to enable a wide range of pumping duties to be handled efficiently and conveniently. The pumping capacity of the station is divided equally between the South End and the South Essex companies. By 1956, the reservoir proper had virtually been completed, though the top water level would not be reached for some time. A road runs along the main embankment, and away on the western shore, the sludge pipeline is carried to the lagoons, which receive the wastewater from the treatment plant. Right at the other end of the reservoir, the smaller dam had been completed, and the pumping station here was demonstrating that the removal of water from this appendage reservoir to the higher level was well within its capacity and could effectively prevent any threatened flooding to the south.